Hello again, organic chemistry students. For our last little discussion for this chapter, we're looking into degrees of unsaturation, which is a concept that you can use especially when we eventually cover NMR, or nuclear magnetic resonance spectroscopy. Degrees of unsaturation, it's a technique to determine whether you possibly have any pi bonds in your molecule or a ring or rings in your molecule. Then you can combine this technique with IR data, mass spec data, and NMR data to have an idea of what the actual structural layout of your molecule actually is. And it's based off of this general formula. The number of carbons in your molecule, you can have at most twice as much carbon plus 2. That's the total number of hydrogen you can have at maximum. For example, if you have 1 carbon, then 1 times 2 plus 2 would equal 4. CH4, that's methane. If we have a fully saturated alkane of 2 carbons, 2 multiplied by 2 plus 2, that would get us 6. And so ethane is C2H6. If, of course, it was, say, 10 carbons for our N value, well, then the maximum number of hydrogen that that molecule could have if it was fully saturated would be 10 multiplied by 2, then adding 2 to that will get us to 22. So a fully saturated decane would be C10H22. Every time that you have a pi bond, you need to have lost 2 hydrogen in your molecule. And every time you have a ring, that also means that 2 hydrogen are missing from that fully saturated formula. So if you have less than the maximum number of hydrogen, then that's a way of figuring out how many potential pi bonds or rings or both you have in your formula. For example, looking at pentane, C5, the maximum number of hydrogen would be 5 multiplied by 2, and then adding 2 to that, which gets us 12. If we have a formula of C5H12, the maximum number of hydrogen that a 5 carbon molecule can hold is 12 hydrogen. So we take the 12 maximum hydrogen minus the 12 that are already in the molecule. That gets us to a value of 0. And then dividing that 0 by 2 gets us 0 degrees of unsaturation. That means that there are 0 pi bonds and 0 rings in your structure. If we look at C5H10, same number of carbons, so the maximum number of hydrogen was 12. But this chemical formula has 10 hydrogen. So 12 minus 10 gives us 2 hydrogen. 2 divided by 2 gives us 1 degree of unsaturation. That 1 degree of unsaturation means it is either a pi bond or that structure is a ring, has a ring in it. And so our actual structure is given to us. That would be, instead of pentane, that would be 1 pentene, or just pentene. And the double bond is essentially removing 1 degree of unsaturation worth of hydrogen. Now, if you have a triple bond, that would be 2 degrees of unsaturation. That's the same if you had 2 rings, a ring and a double bond, 2 double bonds. But a single triple bond, it has 2 pi bonds in it. Each one is a degree of unsaturation. So if we take a 5 carbon molecule, the maximum number of hydrogen it can have is the number of carbon times 2 plus 2 getting us to 12 hydrogen. The actual formula we're given, C5H8, has 8 hydrogen. 12 minus 8 would be 4. 4 divided by 2 is 2 degrees of unsaturation. So that 2 degrees of unsaturation, if we just had the chemical formula, then you should be looking for information like from an IR, mass spec, NMR that implies you have a 2 double bonds, 2 rings, a double bond and a ring, or a triple bond, because those would all equal 2 degrees of unsaturation. Getting back into the formula for C4H6, well, let's look at what the degrees of unsaturation would be there. We have 4 carbon in our molecule, so the maximum number of hydrogen are 4 times 2, which is 8, then adding 2 more to that gives us 10. If we take the maximum number of hydrogen of 10, subtract the actual number of hydrogen 6 from that, 10 minus 6 gets us 4. Now 4 divided by 2, because each pi bond in each ring is using up 2 hydrogen, so that difference of, or I should say, that difference of 10 minus 6 hydrogen giving us 4, 4 divided by 2 is 2 degrees of unsaturation. I was trained to call that DoU, degrees of unsaturation, but you may also see the term units of hydrogen deficiency index, HDI. Now, DoU, HDI, or DU for degrees of unsaturation, all equivalent. But the key here is, for C4H6, that formula has 2 degrees of unsaturation, which means you have multiple options to look for. It could be the result of 2 double bonds in your system, and those may be spaced apart, they may be conjugated like all the way at the left side, they may be on the same, connected to the same carbon. That would be the second option in the 2 double bond column. The dot is used to indicate a carbon where 2 double bonds are connected. We use that in order to help distinguish those are 2 double bonds and not one single double bond in our molecule if we were just to draw them continuously. Now, every pi bond counts as a degree of unsaturation. If you have 2 degrees of unsaturation, that could instead be from a single triple bond. Each ring is also worth a degree of unsaturation, so perhaps C4H6, perhaps you're looking at an isomer that has 2 rings in its structure. Also, if a ring is worth a degree of unsaturation and a double bond, or I should say a pi bond is worth a degree of unsaturation, then maybe your molecule has a ring and a double bond in it. And so here we're looking at all the possibilities of isomers of C4H6 where there would be 2 degrees of unsaturation, either 2 pi bonds from 2 double bonds, 2 pi bonds from a triple bond, or 2 degrees of unsaturation from 2 rings, or a ring and a pi bond that both add up to 2 degrees of unsaturation. For your hydrogen deficiency index or degrees of unsaturation, as you get beyond just carbon and hydrogen, other types of atoms can interact with the overall formula that we're going to use for degrees of unsaturation. If you have a halogen, we're going to treat that in our math as if it's having a hydrogen, because it's not really reducing, its presence does not imply we needed a pi bond or a ring, or we're losing a certain number of bonds needed to have our maximum technical number for a 0 degree of unsaturation. So if you have a halogen, you treat that as just another hydrogen. If you have an oxygen atom, these do not affect your degrees of unsaturation. Because essentially, if you have a 2-carbon molecule, you should have 6 hydrogen. If you add an oxygen there, it's basically spacing out the final hydrogen away from a carbon. You still have the maximum number of hydrogen in the end. If you have a nitrogen in your molecule, well then, where a carbon at the end of a molecule could hold 3 hydrogen, nitrogen at the end of a molecule can only hold 2 hydrogen. So effectively, let's see. Well, actually, I should rephrase this as you're essentially replacing a hydrogen on a carbon with an atom that can hold potentially 2 more or 1 additional hydrogen. And so we're essentially adding to our formula the number of nitrogen in our molecule. So the total formula for degrees of unsaturation is take the sum of twice the number of carbon in your molecule, add 2 to that number, add the total number of nitrogen atoms in your molecule, subtract the total number of hydrogen, and subtract the total number of halogens like chlorine, bromine, iodine. Once you get that total number, divide that number by 2, and that will get you your total degrees of unsaturation. For example, in ethylamine, we have 2 carbons and a nitrogen. Now, 2 times the number of carbon would be 4. 4 plus 2 would be 6. Adding 1 from the nitrogen now gets us to 7. In our formula, we have, let's see, 2 times 2 carbon is 4, plus 2 is 6, plus 1 nitrogen is 7. Minusing the number of hydrogen in ethylamine, we have 1, 2, 3, 4, 5, 6, 7. We have no halogens, so that ends up being 0. 0 divided by 2 is 0 degrees of unsaturation. So we should not see any pi bonds, and we should not see any rings in our molecule. Similar to ethane, where it's just 2 carbons, so 2 times 2 carbons is 4. 4 plus 2 is 6. Subtracting 6 hydrogen, that gets us to 0. And we don't have any nitrogens or halogens, so we don't have to worry about that in our formula. Essentially, in your notebooks, have this entire formula written. 1/2 times the quantity, 2 times the number of carbon, plus 2, plus the number of nitrogen, minus the number of hydrogen, minus the number of halogens. And at that point, you have your degrees of unsaturation. And each time you have a degree of unsaturation, like 1, 2, 3, 4, that's telling you the number of double bonds you might have, because each double bond has 1 pi bond, or it's telling you the number of rings that you have in your molecule, potentially. If it's greater than 1, then you might have multiple rings, multiple double bonds, a single triple bond, or a combination of a ring and a double bond. And if you have more than 2, well, then it could be any combination. An HDI or a DoU of 3 could imply a triple bond, and either a ring and a double bond could imply 3 double bonds or 3 rings, or any combination of double bonds and rings that adds up to 3. So yeah. Glad to have had you all for this little introduction into degrees of unsaturation. Hope you're all doing well for organic chemistry in your semester. And as always, wish you all the best, and peace.